Hello everyone, my name is Ivan Suja and today I will be presenting my Kaggle notebook project. It's called CVE Sentinel. So why I create this? So the first thing is cybersecurity moves fast. Every year, around 25,000 new vulnerabilities are published and manual analysis just can't keep up. This is CVE Sentinel, a multi-agent system I built with Gemini API to automate vulnerability research and exploit generation. So let's dive into the Kaggle notebook. So in here you can see the configuration. So instead of a single chatbot, I built a dedicated pipeline. So if we see down here, here's the tool list that will be used by the main agent, and this is the pipeline. So first of all, we have a researcher agent right here. It's called researcher, and then we have an engineer, exploit engineer, to write the proof of concept code. So the first is the researcher that will be able to fetch the live API data of the CVE vulnerability, and then the last is the critic. So it's the senior critic to audit safety and provide fixes and solution based on the CVE data that available from the researcher agent. So let's see it in action. So here's I initialize the model, create the orchestration pipeline so it can talk to each other, solving problems from the live data. So let's see it here. So here's one of the demos. So here's the scenario. One, logic and permission vulnerabilities for testing the accuracy of the data. So here we are taking one of the recent CVE 2025-7195. So this is a logic bug involving file permission chmod. So the agent must identify that this is a local attack vector local, and require the user to be in specific groups. And the success criteria of this scenario is the engineer should write a bash or Python script that checks for group membership before attempting the exploit. So here's how we call the previous pipeline of the agent. So it will run the research agent, the exploit engineer agent, and the senior critics agent. Here we give the prompt that analyze CVE. We'll give the CVE number directly. So here's the orchestrator, the researcher, and the engineer, and finally the critic before it shows us the final result. So first thing first, the researcher in here is starting analysis to find the information more about the CVE 2025-7195, and then next thing is the engineer will be take over. Okay, then it will write down the code. It's not just a script snippets, but it includes error handling, system checks, backups, and etc. that are used to proving that this is exploit. You can try this on your own to verify whether the system is actually vulnerabilities to this kind of exploit. So here is written in Python, and you can just check it if it's the system is vulnerable with the aforementioned CVE. So after it gets the data about the CVE, it writes simple information like here's the summary finding, and then I already mentioned earlier the proof of concept code by the exploit agent, and then the last is the remediation mitigation. So it's finally the parts of the critic agents. So the critic agents will see the proof of concept code, whether it's malicious or not. I mean, is it dangerous or not to run on your device on your system to verify the vulnerabilities based on the proof of concept codes that given by the exploit agent, and then it will tell the remediation and mitigation part and evaluate the overall solution that given and the proof of concept code. So whether it's a logic bug or a kernel exploit code like dirty pipe or Java RCE like or shell and other many vulnerabilities that are already known in the CVE database, so this multi-agent architecture can adapt its reasoning to the specific threat type. So let's see the second one. So it's the remote code execution. We still give the CVE and it will give us the similar steps to the previous scenario. Here is also writing the proof of concept codes and writing the final report remediation as well. Here's another one showing the dirty pipe exploit. And the final is the hunter mode. So this is the reasoning test. So this is the case where we give no CVE ID. So the researcher agent must be able to use specific tools that calls our CVEs to find the CVEs that we want that mentioned. So in contrast to the previous demonstration or scenario, here we can just find the most recent critical vulnerabilities in Apache HTTP server. So it will just directly instruct the researcher to use the tools to find the specific latest recent critical vulnerabilities in Apache HTTP server, and then it will write the proof of concept, the exploit agent, and then the senior critic agent will be reviewing and finalizing the whole report. So here we can see the result. It's pinpoint a vulnerability of CVE 2025-53020, Apache HTTP server memory leak or denial of service. So yeah, we can see this executive summary, the proof of concept codes. It's written in Python script and reviewed for safety. Okay, and then the last one is official remediation steps and additional mitigation and best practices recommendation as well. So yeah, that's overall the scenario that we have. So in this notebook we have successfully demonstrated the CVE Sentinel system by decoupling the tasks of research engineering and auditing into specialized agent. We achieve a higher accuracy, safer code, and versatility. So this architecture serves as the blueprint for the next generation AI-assisted security operations centers. So this is the power of agentic AI that turned the raw vulnerability data from the OpenCVE database into actionable intelligence in seconds. So you can check out the complete code in the Kaggle notebook that attached to the submission as well. So yeah, I think that's all from me. Thank you.